So I'm going to talk about hypothesis testing. This is where we test if something they're saying about a population is actually true based on some sample data that we're getting. So we make a decision about a value of a population parameter. So it could be the population mean, it could be a proportion, it could be multiple things like that. But we have our null hypothesis. This is the statement of equality. This is what they're starting with. It denotes a theoretical value, a historical value, or a production specification. And then we have our alternate hypothesis. This is what we're testing. Like, do we think it's more? Do we think it's less? Do we think it's just different? And if we can reject the null hypothesis, then we'll accept the alternate hypothesis. And just a couple of notations. So H sub 0 or H naught is denoting our null hypothesis. And H1, H sub 1 or H sub A, depending on what source you're looking at, that denotes our alternate hypothesis. So the null hypothesis, this is really kind of a big deal here. The null hypothesis is always a statement of equality. So something equals something, where K is a specific value. The alternate hypothesis states that the parameter is less than, greater than, or not equal to a specific value. So it has to be one of those three. And we're going to practice setting this up right now. So a car manufacturer advertises that its new subcompact model gets 147 miles per gallon. Let mu be the mean of the mileage distribution for these cars. You assume that the manufacturer will not underrate the car, but you suspect that the mileage might be overrated. So what should we use for the null hypothesis? This is what are they claiming? What is going to be true? And remember, this is a statement of equality. So we're going to have mu equals something. Well, what is the car manufacturer claiming? They're claiming our average equals 47. Now, what are we assuming? We're assuming, and so these are going to look exactly the same. We're going to have this and we're going to have 47. It's the sign in the middle that's going to change. Are we assuming that their average is actually more than that, is less than that, or is just different? And that's where we have to read carefully. So we suspect that the mileage might be overrated. We think that this is too high. That means we think that mu should actually be less than. So our null hypothesis is mu equals 47, and our alternate hypothesis is mu is less than 47. All right. So here's our kind of our different tests and the names of them. And this is more useful if you're going to do these by hand, which this video, I'm going to walk you through how to do these kind of the hypothesis testing on the TI-84 calculator. So a left tail test is where we think it's less than. A right tail test, we think it's greater than. And a two tail test is not equal to. So if you remember graphing these from when you were in algebra classes, something less than, it's an open circle going to the left. So, left tail. Greater than is an open circle going to the right. So a right tail. And then a two tail test is just saying not equal to, which means it goes both direction. Hence the two-tail test. All right, so our hypothesis testing procedure. So the first thing we need to do is select an appropriate hypothesis. So we got to figure out what it is we want to test. Then we would draw a random sample to actually calculate about that sample our test statistic. So we calculate our test statistic, and then we'd assess the compatibility of the test statistic with our original hypothesis. And then we're going to make a conclusion within the context of the problem. Here's how our formula would look if we were kind of doing it by hand. But once again, I'm going to have you guys do this on the calculator because with our time constraints and our online learning, that's just going to be much easier. So our p-value, this is, if we're assuming the null hypothesis is true, this is the probability that the test statistic will take on values as extreme or more extreme than the observed test statistic. So what that means is our p-value is the probability that we will get numbers way different than what we got. All right, and so the smaller the p-value, the stronger the evidence is against the null hypothesis. And we actually have a number that we're going to test this against. But a very small p-value means that we have very little chance of it being more extreme than that. And if we get extreme than that, then it kind of causes some problems. We have two different kinds of errors. So type 1 is if we reject the original hypothesis when it is in fact true, that's a type 1 error. And type true is saying, okay, what they said is true, but it's in all actuality false. So that's a type 2 error. We can't tell these type of things. You just need to be familiar with these errors. So, and our level of significance is our probability of rejecting, is basically the probability of making a type 1 error. So we want our probability of making an error to be as small as possible. So they actually give us our level of significance to test things against. All right, how do we conclude the test of a p-value and the level of significance? So these are really important. If our p-value is less than or equal to our alpha, we're going to reject the null hypothesis and say that the data is significant enough to accept the alternate. If our p-value is greater than our level of significance, we do not reject. All right, let's look at another example here. So Rosie is an aging sheepdog in Montana who gets regular checkups from her owner, the local veterinarian. Let X be a random variable that represents Rosie's resting heart rate in beats per minute. From past experience, the vet knows that X has a normal distribution with a standard deviation of 12. The vet checked the Merck's veterinary manual and found that for dogs of this breed, the mean heartbeat is 115 beats per minute. Over the past 6 weeks, Rosie's heart rate in beats per minute is measured. The sample mean is 105. The vet is concerned that Rosie's heart rate may be slowing. Do the data indicate that this is the case? Well, we're going to kind of practice finding some things. So let's figure out what the null hypothesis is. So our null hypothesis is really saying, okay, our average heart rate, and I should use a colon here, our average heart rate is 115 beats per minute. So our alternate hypothesis is, okay, what do we think is happening with Rosie? Well, we think Rosie's heart rate is slowing, so we think it's less than 115 beats per minute. And we're going to test this, and we can't actually do a test on this because we don't know a level of significance, and I actually haven't showed you how to do it on the calculator yet, but there's another way of practicing finding the null and alternate hypothesis. But we would end up typing this data into our calculator, and it will do a lot of the work for us. So if you want to know how to do it by hand, here's all the page numbers in our stats book that walk us through that. But we're going to use the calculator. This page is going to be huge. The yellow boxes down at the bottom tell you what situations that we are in and what test you're going to do. So to get to this, you click Stat. So let's pop up the calculator just so you can see where we're at. So if I push Stat, here, let's actually clear this out, and then you can actually see my key sequence. So Stat, and you can see Test over here. I want to point out something else to everybody as well. If you're watching this video, you've probably already done confidence intervals, but I do want to point out to you that you could do confidence intervals as well on the calculator. So here's our Z interval, our T interval. So those are available on here as well. But here's all of our tests, our hypothesis tests. So a Z test, a T test, a 2-sample Z test, a 2-sample T test, a 1-prop Z test, and a 2-prop Z test. And by prop, this means proportion. And so what do these things mean, this 1 through 6? Well, it breaks it down right here, what it means. So we'll use test 1 when we know sigma. We'll use test 2 when we don't know sigma. We'll use test 3 if we're given 2 samples and we know sigma on both of them. We use test 4 if we have 2 samples and we don't know sigma on either one. We use sample 5 if we're just given 1 proportion that we're testing. And we'll use test 6 if we're given 2 proportions of things to be testing. So kind of keep this in mind. This is our keys to be able to do these on the calculator. So let's do an example. This lays out everything that we need to find, okay? So Professor Jennings claims that only 35% of students at Flora College work while attending school. Dean Renata thinks that the professor has underestimated the number of students with part-time or full-time jobs. A random sample of 81 students show that 39 have jobs. Do the data indicate that more than 35% of the students have jobs? Use 5% level of significance. Okay, so nowhere in there does it say anything about a mean or a standard deviation, which means this is actually a proportion test. So we can look up and see our level of significance. It tells us it's a 5% level of significance. So alpha is going to be 0.05. Okay. Our null hypothesis. This is a proportion. So with our proportion, we are going to say that our proportion, so P equals 35% from right up here. So 0.35. Put a 0 in front of that to kind of separate it. So our null hypothesis saying 35% of students have a job. Well, what is our alternate? They think, or Dean Renata thinks that they have underestimated. So she thinks it's actually higher than that. So we're going to say P is greater than 0.35. Remember when we're doing our null and our alternate hypothesis, the variables are the same and the numbers are the same. It's the signs in between that change. So now we're going to compute a test statistic. All right, so I'm going to pull up this, move stuff around so I can actually see. All right, let's start over from the very beginning here. We're going to go stat, tests, and it is a proportion, and we've only got one, so it's going to be this test number 5, a 1 prop z test. So you can click 5 or go in. All right, so P sub 0, this is our null hypothesis. So it says 35% of the students at Flora College. So we're going to type in a 0.35 here. All right, then it says X. Well, what X wants to know is how many have a job, and N is how many did they talk to in our sample. Well, 81 students is how many was in the sample, and 39 of them have jobs. So our X is 39. And our N was the 81. Now, our prop here. So this is exactly as it shows up right here. So we're saying P is greater than our P sub 0. So we're going to move over to is greater than, and then we're going to push enter. And then the color doesn't matter because we're not going to draw anything. We're going to calculate this. So go ahead and push enter on calculate, and it gives us a bunch of information. All right, it gives us a bunch of information. The Z, this is our p-value. This is actually the proportion that is based on our 39 and 81, and then N is our 81. So now we're going to fill out this information here. So I'm going to move the calculator over here so I can see. All right, our Z or T statistic. So we could see on here that it is a Z. So Z equals 2.48. That's our test statistic. That's what goes there. Our p-value was 0.0066. So that's what goes there. Now, based on our answers, are we going to reject or fail to reject the null hypothesis? Well, let's go back here and see what happens. Oops, too far. If our p-value is less than our level of significance, we reject it. If it's greater than, we do not reject it. So let's bounce up here. Is our p-value less than our level of significance? So is 0.006 less than 0.05? Yes. So we are going to reject the null hypothesis. All right, interpret the results in the context of the problem. All right, so if we're rejecting that this is the proportion, the way we're going to interpret this is, so we're going to reject that only 35% of students have jobs. Students have jobs, and accept the proportion is higher. So until we test the next one, we're going to accept that the proportion is higher. So this is how we do a hypothesis testing. This is how we test if something is true or not. I'm going to see if I can get all these changed back to normal color here. There we go. So here's a full-on hypothesis test. Let's try another one. All right, a comparison is made between two bus lines to determine if arrival times of the regular buses from Denver to Durango are off schedule by the same amount of time. For 51 randomly selected runs, bus line A was observed to be off schedule for an average time of 53 minutes with a standard deviation of 19 minutes. For 60 randomly selected runs, bus line B was observed to be off schedule for an average of 62 minutes with a standard deviation of 15 minutes. Do the data indicate a significant difference in average off-schedule times? Use a 5% level of significance. All right, well, let's go through and do this all again. Our level of significance here, I'm going to lock that down so I stop moving it. So our level of significance here is going to be okay, it keeps changing on me. There we go. Is going to be 0.05. That's at 5%. All right. Our null hypothesis, when you are given two different samples, we are testing whether we think they are the same or not. So we are going to say under this one that the mean of one equals the mean of the second. That's what we are testing. So our alternate is, do the data indicate significant difference in average off-schedule times? So they don't want to know if one's bigger or smaller. They just want to know, are they different? So are we testing? We're seeing if mean 1 is different than mean 2. All right, compute the Z or T test statistic. All right, well, here's the thing it's talking about. It is saying that for the random sample, here's our mean and here's our standard deviation. It does not tell us anything about the population standard deviation. That means, we're looking at our test here again, we are doing a two-sample test, but it is a Z or a T. We don't know the standard deviation of the population, so it is a T test. So that's this number 4. All right. If you have data that you can type in, you would type it in, and then your lists, it will automatically do it for you. However, we don't have that data. We're going to use stats. So it's going to ask us for the mean of sample 1, and then the standard deviation of sample 1, and then how many were in that sample. And the same for sample 2. So I'm going to move this around and then type this in. All right, so our mean for sample 1 was 53 minutes. Our standard deviation was 19. And for sample 1, we had 51 randomly selected. All right, for sample 2, it said it was an average of 62 minutes with a standard deviation of 15, and there was 60 buses there. All right, are we testing that they're not equal, that the first is less than the second, or the first is greater than the second? Well, look back at our null hypothesis. We're testing that they're not equal. So that's going to be that one. Oops, didn't mean to do that. So we're testing that. Pooled, we never pool these. Color doesn't matter, and we're going to do a calculate. Okay, so here's our T critical value, our P value, and then all the information we already typed in. So let's write all that down here. Once again, I'm going to move this so I can mess with things. All right, so our T statistic. So we got T to equal negative 2.735. Our p-value was 0.0074. And so then based on our answer, shall we reject or fail to reject the data? All right, so now we're looking, is our p-value less than our level of significance? Yes, it is. So we are going to reject the null hypothesis. And does that make the data statistically significant or not? Okay, the data is, if we reject it, is statistically significant. Probably spelled this correctly. All right, can interpret the results in the context of the problem. So we believe there is a difference in the off-schedule times for the two bus routes, or bus lines, I guess it is. So that is really what it's asking. So we're kind of just answering the question for the most part. And that is how we do hypothesis testing. So it's a fairly straightforward thing once you know how to use the calculator. But if you have additional questions, feel free to hit me up on the Google chat. And I hope you enjoyed this. This is our last unit in statistics that we are going to cover this year. So thank you for spending the year with me, and I miss seeing you guys in my classroom.